Welcome to the part 2 video of module 6 classes and oops, which is oops bird's eye view. We have discussed generically about class and object in our last video of this module, that is classes and oops. Now we will see the textbook definitions of class and object. Let us begin with class. So Python class is a device used to implement new kinds of objects in Python that support inheritance. Now the question arises, how to create a class? As we have already seen, classes are created with a new statement, that is the class statement. This one, class statement. We use class keyword, and they also support inheritance. Inheritance is a mechanism of code customization and reuse above and beyond anything. From the class, we make an object. The object is an entity that has state and behavior. It may be anything from real world object like the mouse, keyboard, chair, table, pen, human, lion. Human is a class, and Charan, Krishna. Krishna was human 5,000 years before, and he lived in Dwarka. So obviously he is an object. He is not a class. Then everything in Python is an object. Everything in Python is an object. I have been repeating this like a broken tape recorder. And almost everything has attributes and methods. So all functions have a built-in attributes: trailing double underscore doc, leading double underscore, which returns the doc string defined in the function source code. Then just now we have said object is the one which has state or attribute and behavior or method. Then what do you mean a method or behavior? What does that mean? The method is a function that is associated with an object. In Python, a method is not unique to class instances. Any object type can have methods. Here is a simple example. Class is car. Of course, a car is a category or a class. But what type of car? If you have a specific name, Tata, Nexa, or Bench. So if you have a specific model, then that is an object. Car, bike, scooter, these are all categorization of transport modes. But a pulsar, a CBR, a CBZ, these are all actual object, real entities, or names of the real entities, names of the real objects. That is the difference between a class or category and an object. Then we have inheritance. Next is okay. Next, okay, it's inheritance. Next, what we are gonna look is inheritance. Inheritance is the capability of one class to derive or inherit the properties from another class. Basically, we always look for the asset inheritance, land inheritance, house inheritance, not of knowledge inheritance. I hope uh, present day present day generation will think about knowledge inheritance from our ancestors, and it represents real world relationships well. It provides the reusability of a code. We don't have to write the same code again and again. Also, it allows us to add more features to a class without modifying it. Then what we have is next in the pipeline is polymorphism. It is an important feature of class definition in Python that is utilized when you have commonly named methods across classes or subclasses. So this allows functions to use objects of any of these polymorphic classes without needing to be aware of distinctions across the classes. So in ahead, as we move ahead, we will look into polymorphism in detail. So that's for you just adjust with the definition. Then next is data abstraction. In Python, data abstraction is the process of hiding the real implementation of an application from the user and emphasizing only on usage of it. Like it is as similar to utilizing a laptop. You know how to use it, but you don't know what is there inside and how they communicate with each other and how they function. Similarly, you eat idli sambar, but you do not know how they are made and what material it consists of. Not everybody, very few people know this, but you cannot see what is there inside the material. Similarly, we cannot see what is there inside the laptop, but what we can do with the laptop is we can use it. That is data abstraction. Data abstraction. So, abstraction focuses on hiding the internal implementations of a process or method from the user. That's what I was saying. In this way, the user knows what he is doing, but now how the work is being done. The user knows what he is doing, but he does not know how the work is being done. Then finally, the most crazy topic, that is encapsulation. Encapsulation offers a way for us to access the required variables without providing the program full-fledged access to any of those variables. Updating, modifying, or deleting data from variables can be done through the use of methods that are defined specifically for the purpose. And the benefit of using this approach to programming is improved control over the input data and better security. So to put this encapsulation in a simple words or layman's language, it is like you have a important material that should be transported to somewhere else. So what will you do? Will you transport it like that, or will you pack it in something else? So you will put it in something else, you will capsulate it, and then you have another material you want to send to somebody else. Like you have 10 types of materials, 10 types of different materials, but you want to send it in a common vehicle. What will you do? You will pack it separately. Yes or no? You just pack it. Same thing we will do. In one class, you have a different methods. So if you mix all methods, then it is impossible to have a number of variables, because all namespaces will become equal. So you cannot have a more variable names. So that's why what we'll do, we'll encapsulate each method. Each method is completely different with other methods. So if you use x is equals to 20, x x or some name as a variable in your method, you can use the same name variable in another method also. That is the power of encapsulation. So with this, we will jump into the Jupyter code, Jupyter notebook, and we'll do a bit of coding on this. Here, I will be taking a real world example to explain all these concepts. Let me jump into it. So this is Oops Bird's Eye View. We will begin with class definition. Class is nothing but a category and with a set of rules. So our class is programming language. Programming language. This is our class or category. And so first step, what we'll do, so now we will build our class. Means it is not this, whatever you see here, whatever is there in front of your eyes, which is a blueprint to make a real objects. What are the real objects? We will look after some time, but here this is the blueprint. So first I have to construct the class or category. I have to lay out some rules to construct a category. So what are those? Okay, forget about name, one attribute, developer, year developed, type of the program, coding system, license, application, integration, execution, platform. So now I am attaching all these attributes to the instances. Okay, you just try to remember those words, but don't afraid of those words. Okay, slowly we have to use the actual programming words, so that it would be easy for you to communicate with your fellow colleagues. So this is how I have attached all the attributes. Now what else is left? I have to add behavior or methods. So here I am preparing those also. So what is the one function I have built? That is, tell me applications of that programming language. Okay, so now let me execute this. No errors, absolutely fine. So your programming language blueprint or layout is ready for the use. This is also known as the class with attributes and methods. Class with attributes and methods. So now our blueprint is ready. Now we will make object. Object is a real entity. Now we'll see what is that real entity in programming language. So the real entities of programming language category are, or class, or the are the following, which is high level programming language includes Python, Java, JavaScript, PHP, C++, Objective C, COBOL, Perl, Pascal, Lisp, and Swift programming language. So now we will see what is programming language. This is a class type. That's what we have built using a class statement. Now we will build our first real world object, that is Python object. So Python, so obviously we have to use a programming language class to build a Python object. Name of that object is Python. Who has developed it? Guido van Rossum. Then and which year he has developed it? 1990. Is it low level or high level language? It is high level. And then applications of it, scripting, adopts, basically both. And is it license is open source? And another machine learning, artificial intelligence, big data, graphical user interface, robotics. These are the applications, and it can be integrated with other types of languages. Those are C, C++, Java, and how it interprets the executes the code line by line. And is it platform independent? Yes, it is platform independent. And how it compiles the code? It compiles and then interprets the code. So this is our platform. It is all about our Python programming language, and these are all the attributes of that class. And inside, if you observe, you have strings, you have list, you have list also. Okay, let me execute and let me check. I want to get application attribute. What are the applications of Python object? Because Python is a real world object. Programming language is a classification. There are different types of languages: spoken language, programming language, and there are other languages. So this is one. So that is a class, and the Python is a real world entity of programming language class. So now we got applications of Python object, Python programming language. Let's list, that's fine. Now I want to use method. I have written a method in blueprint of class programming language. So I want to call that method, and I'll see Python, our object. Python is our object, and then dot tell me applications of this object. Which object? Python. Let me check what are the applications. See here, Python has the following application. First, machine learning, artificial intelligence, big data, GUI, robotics. If you go back, I have laid out this behavior, the tell me applications behavior in my blueprint. That's the reason I am able to get this method here. So similarly, create a Java object. Java was developed by Sun Microsystems 1995, high level, oops, open source, and applications, Android, GUI, big data, web, desktop application, so on and so forth. So let me use this tell me dot application again, that method. See, this is the benefit. You have laid out, you have built this method only once in your class blueprint, whereas you can use with any object that you have written with this class. See, it has giving the clear cut results. That's the power of classes and oops. See how simple, how easy it is making our lives. Then, so we have seen enough example. We have built two real world objects also. So now what we'll do is we will see a simplest way. What is polymorphism? So joint, I have built I have defined a function. The name of that function is joint, and it consists of two parameters. So when I want to invoke this function, I have to send two arguments inside the that callable parenthesis, so that because I have given two parameters. So let me check. So when I use integers, now this function is as given an int. Sorry, it is not an int. It has done. It has done. Just a minute. I'll check whether I have used a return. Fine. It is an int because I have used a return to result a return to give back the result. So obviously, I'll get int. So and the operation it has done was addition. So and it is int. So we will invoke that function again, but this time we will send two string arguments. Initially we have sent two int arguments. Now we will send two. Now we will send two string arguments into the joint. So now we'll see. Now we got Radhe Govinda, Radhe Govinda. So now we got Radhe Govinda. Now what it has done is it has concatenated. So that is what we call it, and the type of object is string. So that's the polymorphism. Irrespective, see, your operator remains same, assignment operator remains same, but depends upon your object, the result object also varied. So it has done concatenation with the same operator. We have done addition with the same operator. So this type of nature of the Python is called as polymorphism. So with this, we have reached to the end of part 2. That's Oops Bird's Eye View in module 6, that is classes and oops. I hope you enjoyed it, you liked it. You just refer this video to others, and if you haven't watched the previous videos, please go back and watch those videos. You will actually enjoy it. It will give you a plenty of information. And keep liking it, keep subscribing it, and keep sending these videos to your friends and family so that everybody can get benefit out of it. With that, thank you and see you again in another video of module 6.